Good afternoon. My name is Kamal Hathi. I'm the general manager for the Power BI product. And thank you so much. Thank you again for being here on the first day of the conference. Everybody have a good time so far? Yeah, okay, great. Great. Did you enjoy the keynote in the morning? Was fun? Yeah? Cool. So we have another keynote now, and that's going to be amazing as well. It's going to be a great keynote. And we have Alberto Cairo, who's going to come and speak to us. And for those of you who don't know, Alberto is a very well-known, accomplished person in the data visualization space. He's a journalist. He works on multimedia. He's a professor. He actually is, I'm reading up here now, the Knight Chair in Visual Journalism at the School of Communication at the University of Miami. And that's an amazing program. He's the author of many books. And to give you an idea of what kind of person he is, very, very straight. He says exactly what he sees, very engaging. And to get an idea about Alberto, his last book is called The Truthful Art. So you'll get a lot of truth today from Alberto. And so I'm really excited to have him join us today. So Alberto, please join us on stage. Fantastic. All right. Have a great keynote. See you.
Thank you. All right, welcome. Well, this is a huge room. Well, thank you for having me here. This is exciting. So when I was getting ready for this keynote, I was in touch constantly with the wonderful team, the wonderful Power BI team from Microsoft. And the first question that I asked them is, what do you want me to present about, right? I do graphics, I do infographics, right? Graphics for presentation and for communication. And I said, well, perhaps you can do a presentation to get people excited about the possibilities of data visualization and infographics. And I said, well, certainly I can do that. And then they said, well, perhaps you can also talk a little bit about certain principles of data visualization. I said, well, I can also do that. I said, well, perhaps you can talk a little bit about the possible problems that data visualization may pose to designers. And I said, well, I can certainly do that. I teach an entire semester about that. And then I asked, how much time do I have? And they said, you have 1 hour. And I said, all right, that's going to be a little bit of a challenge. So let's see what I can do. So what I would like to do today is to convince you of 3 main facts, right? The first fact is that data visualization is not magic, right? That's the first thing that I would like you to convince you of. The second one, which is related to this first one, is that anybody can learn to do good visualization, considering that you apply certain principles and you learn to use certain tools. But then at the same time, we must not forget that the tools are not everything. Principles are also really important. The reason for that is that at the same time, visualization needs to be handled with care because the possibilities of misleading the public by using bad visualization or visualization that is poorly designed are great. So I'm going to begin with the very, very, very basics, and then I'm going to walk you through, I'm going to give you a tour through the world of data visualization. First of all, I'm going to define what I mean by data visualization. For in the 2 books that I have written so far, that have been published in English so far, in the American market, I define visualization as any kind of graphical representation that is intended to let you see what you cannot normally see. The joke that I usually make in classes when I explain this concept to students is that a good visualization gives you superpowers. It gives you X-ray vision. It lets you see through the huge amounts of data. It lets you extract trends and patterns from the data that you have in front of you. That's the key concept. And we do visualization because we have a great need of analyzing data, understanding the data, and then we need also to communicate the results of that analysis to other people. Those are the main purposes that a visualization can have. Data visualization is based on the idea of visual encoding. In the jargon of data visualization, we say that we begin with the data, and then what we do with the numbers in our Excel spreadsheet or in our database, and then what we do is to map those numbers onto spatial properties of objects, right? So we represent the data proportionally using those objects. So we could represent the data using the height of objects, for example, in a bar chart, the length of objects in a bar chart, the position of objects in a dot plot. We could represent the data using objects of different sizes, like bubbles. That's another possible method of encoding or method of representation. We could use angle to represent the data, like in a pie chart. We could use line thickness. We could use color shade. All those are called methods of encoding, and this is the key idea behind data visualization. Now, the question is always, when we're going to represent the data, is which one of these methods of encoding is more appropriate, right? Because not all of them are appropriate depending on what you want to achieve. Later on, I'm going to give you a couple of ideas that can help you decide how to choose the best way of representing your data. So just to give you a real-world example of how powerful visualization can be, I'm going to show you just a very quick screenshot of a data set. It's a huge data set of thousands of records of global temperatures in comparison to the 20th century average, measured in Celsius degrees from the year 1000 up to the year 2000. If I show you that, this is just a couple of screenshots of the data set, your brain will not be able to understand anything, because a table, a numerical table, which is also a form of visual representation, the only task that it enables you to do is to see every individual number. But you cannot really extract trends and patterns in the data from a table. It's really, really hard. It is only when we take all these numbers and we map them onto spatial properties that we can start seeing trends and patterns in the data. That data set is the origin of one of the most famous and one of the most relevant visualizations ever created, which is commonly called the hockey stick chart, in case that you're interested in searching for it in Google, created by a group of environmental scientists back in 1998, 1999, and then published in 2001 in the third IPCC report. And this graphic shows you the variation of global temperatures. That's the black line, all right, from the year 1000 up to the year 2000. And the pattern that we can extract from it, from the data now that we have represented visually, is that up to the beginning of the 20th century, global temperatures more or less stayed stable. But then once we get to the 20th century, we get the tip of the hockey stick, right? The global temperatures start spiking up very, very rapidly. The level of uncertainty is also represented in there. As you can see, this, in my opinion, speaks about the power of data visualization, not only to explore our data and discover patterns and trends in the data, but also in terms of persuading people. Because if you believe, I would not say believe, if you embrace the evidence and accept the evidence for climate change, this is one of the most persuasive graphics ever created. Once you see it, you cannot unsee it anymore. It sticks here, and that's another feature of good data visualization. It's persuasive, and it is memorable, Those are the reasons why visualization is becoming so popular in the media, right? It's popular in the media. Places like the New York Times, the Washington Post, the Wall Street Journal, the Financial Times, Bloomberg News, etc., are using more and more visualization every day in their news coverage. And the reason why they are doing that is that they are seeing that people really like visualization. Actually, some of the most popular stories ever published by these organizations and many others are not written stories, are visualizations. They are visualizations, right? For example, the one that you have on the upper left corner, that beautiful graphic created by the Wall Street Journal, was one of the most popular pieces of information published by the Wall Street Journal that year. So this also explains visualization becoming more popular. Another factor for the popularization, the rising popularization of data visualization is the increasingly availability of easy-to-use tools. Okay, these are just a few tools that I use in my daily work. as a journalist and as a professor. So we have Excel, obviously, we have Power BI, we have programming languages that are becoming easier to use. I tend to use the R programming language, but there are many others, like Python. We have free tools to do maps. For example, Quantum GIS, QGIS, is an open source tool to do complex data mapping. I still use Adobe Illustrator to create my static graphics. All these tools have become easier to use than they used to be when I began my career as a designer 20 years ago. And in some cases, they are completely free. And in some cases, they are also open source, all right? And that is absolutely wonderful. Now, as I said before, tools are not everything. So I'm certainly happy and excited about the possibilities of data visualization. I am happy that more and more people, like you all here in this room, are trying to get into visualization, are learning visualization, etc. But as I said before, I don't want to talk about tools, because another phenomenon that I have identified in the past few years is that observing how people design and also read visualizations, I have observed that many people misuse visualizations. They design ineffective visualizations, and that is dangerous and also worrying, in my opinion. And also they misinterpret visualizations when they see them. So I'm going to show you a couple of examples of what I mean. The first one is going to be a fictional example. It's an example that I created for one of my books to illustrate a problem. It is a problem that I have seen in many organizations, but I didn't want to embarrass anyone in one of my books, obviously, so I made up an example based on completely fake data. Let's suppose that you are going to do an analysis of the music styles that university students prefer, right? So, and then you conduct a survey in 1994, asking a sample of 1,000 students, for example, asking them, if you only had to choose one music genre, one music style, what would that be? What would that music style be? And you get the results in 1994, in which 35% of the students say that they like hard rock. That is not true, obviously. That's the music style that I prefer, by the way. So I'm assuming that my students like that, but it's not true. So 35% like hard rock, 25% like samba, 20% like hip-hop, and so on and so forth. That's in 1994. Then you conduct the same survey in 2014, 20 years later, and you get completely different results. And you may notice that on the second chart, I erased the numbers. I'm not showing you the numbers, and there's a reason for that. Reason is that if a visualization forces you to read every single figure in order to interpret the visualization correctly, you are doing it wrong. And that's the reason why I erased the numbers. So I'm going to ask you several questions. I'm not going to ask you to reply to me, but just answer to that question in your head. Has hard rock become more or less popular in the past 20 years? Obviously, it's more popular. We can see the red segment becoming bigger. What about samba? Is samba more or less popular? It's harder, right? Unless that you use your fingers, you do something like that, right? It will be super hard to see if samba is more or less popular than 20 years ago. What about hip hop? It's the same problem, right? This is an example of what happens when we use a tool like Power BI or Excel or many others mindlessly without thinking what the graphic is for. And that is one of the key rules of data visualization. When we are going to design a data visualization, don't pay that much attention at the data, because one problem that my students face when facing a graphic like this is that they see that the data adds up to 100%, and then immediately make the association, if it adds up to 100%, it needs to be a pie chart, because a pie chart is the most common way of representing things that add up to 100%. But that's the wrong thinking. Think about not what the data is. That's important. I mean, you should not overlook that. But think about what the visualization is for. What is the task or the tasks that that visualization is supposed to enable, right? A visualization is an extension of your perception and your cognition. It is similar to a hammer. A hammer has a particular shape because it has a particular purpose. It's similar in a visualization. And in this case, the purpose of the visualization is explicit in the title, how music styles have changed in the past 20 years. But this is not representing change. It is representing parts of a whole, which is a completely different task. How easier it is to see change if we represent the data like that? It's much easier. You don't even need to read the labels. You don't even need to read, the text. You can see things. You immediately see things going up or going down. Well, so this is how you choose among the methods of encoding that I showed you before. Asking yourself, what am I supposed to enable? What am I supposed to facilitate? You always want to make your reader's life or your audience's life easier when you represent data. So this is an example of what happens when a designer doesn't design a graphic well. But there is a complementary problem over here, which is that sometimes what we show, even if we design a good visualization, we cannot really control how people read it. And that's another part of the problem. So let me show you an example that I stumbled upon very recently. Now, living in Miami, Florida, this is a kind of map that I see every year. When hurricane season begins, we get this map all the time in the news, all right? Like a cone, all right, and the hurricane coming closer to Florida, be secure your house, et cetera, et cetera. So this map is misinterpreted very, very often. This is something that research has shown already, that people tend to misinterpret this map. So let me show you how people actually read this map. In order to do that, by the way, I created another fictional example of hurricane map. I invented Hurricane Cairo, category 5, all right, about to hit the coast of Louisiana and Texas down there. And so we see the path of the hurricane, and we see the cone that increases in size. That is called the cone of uncertainty. How do scientists come up with that cone? Well, first of all, they estimate the possible path of the center of the hurricane, and then around that path, they put circles of increasing sizes representing the level of uncertainty of the model, basically. The reason why the circles become bigger is because the future, the far future, is much harder to predict than the near future, obviously. We know that as data people. That's how we read the graphic. That's how I used to read the graphic, meaning that the hurricane could be anywhere within that cone of uncertainty. But that is not how many people read this graphic. When some people see the cone of uncertainty, what they do is the hurricane itself. They see a hurricane growing in size, believe it or not. And why is that? People are not stupid. The problem is that the shape that we are using to represent the data resembles the shape of a hurricane. A hurricane is sort of a circular thing, right? Now, that's part of the problem, but there is a bigger problem. When we talk, and this is something that most of you probably are not aware of, at least it was a complete surprise for me, someone who works with data every single day. I was assuming that the cone of uncertainty represents a 95% level of confidence, like a confidence interval at the 95% level. I was assuming that based on the models, 95% of the time the hurricane path is going to lie within the boundaries of the cone of uncertainty, and only 5% of the time the hurricane could go anywhere else. Wrong. That is not what the cone of uncertainty is representing. Here comes the surprising thing. It's only a 66% level. Whoa, that means that 2 out of 3 times the hurricane will be within the boundaries of the cone of uncertainty. 1 out of 3, 1 or 2 in a dice, if you roll a dice, it could be outside of the cone of uncertainty. So perhaps, this is just an exercise that I did to explain this problem to myself. We should not represent the data this way. We should represent the data that way, showing different paths that the hurricane could take, all right, using a gradient of color, all right, of decreasing intensity to represent the different probabilities of each one of the models. Now, what is the challenge over here? The challenge is that is only showing the center of a hurricane, the center of the hurricane, but it's not showing the actual size of the possible size of the hurricane. So what you're actually showing over here should actually look like that. Now, what is the problem in this case? That if you show people that, they will say, well, the hurricane could go anywhere, right? I mean, scientists don't know anything, right? So sometimes I think that sometimes we need to just basically deliver a much clearer message. So perhaps I came up with another alternative to this map, telling people a very clear message. I censored that, by the way. The full word was there, but I thought that it was not perhaps appropriate for this audience. But anyway. All right, so people misinterpret graphics all the time. So the conclusion that I reach is that the current technological revolution that we are experiencing, which is wonderful, I love all these tools, etc., but it needs to be paired with a revolution of critical thinking and a revolution of ethical thinking, because sometimes graphics are also misused to deceive people, and that's a huge problem. When we think about all these exercises led me to the next thought, which is that what did we used to consider an educated person in the past? When we think about what we teach children in schools, all right, or most common, we teach them literacy, right? We teach them to read and to write things correctly, to interpret written texts. We also used to teach, or we keep teaching, articulacy, which is the ability of expressing yourself through spoken words and being able to interpret also spoken speech, right? But there are two other kinds of literacy that are equally important and that, in my opinion, are not well taught anywhere in the world that I am aware of. The third of is numeracy. And numeracy is not exactly statistics. I'm not advocating for teaching people statistical methods and equations and stuff. But I'm more advocating for teaching people to interpret numbers correctly, critically, and skeptically. That is not well taught. We teach arithmetic, we teach calculus, we teach statistics, but our children are not learning to interpret numbers correctly for some reason, and that is one of the sources of the problems that we're facing nowadays in this country and in many others. And the fourth kind of literacy that we need to focus on is graphicacy, which is the literacy that has to do with designing graphics to explore data and to communicate data, and also being able to interpret those graphics that are shown to us correctly. So what I would like to do next is to give you a very, very quick introduction to graphicacy. What does it mean nowadays to be graphically literate, all right? The main principles of graphicacy. It's going to be like 5 or 6 principles. I'm going to show you an example of each one of them, and then we will close up the session. And then you can go grab a beer or something. Anyway, so the first principle is actually a pre-principle. It's actually something that comes before you even represent your data. So before you visualize anything, you need to make sure that the data is right, that your data is clean, etc. But not only that, you also need to make sure that your data is actually measuring what you think that it is measuring, right? So I'm going to show you an example of what I mean. Yesterday, when I was finishing giving the final touches to this presentation, I am on Twitter all the time, I saw a wonderful map on Twitter. I told you before that I like hard rock, so I saw this map yesterday. Number of metal bands per million people all over Europe, the higher or lower concentration of heavy metal bands all over Europe. I said, this is so great, right? It's so wonderful. But immediately, my BS detector jumped in and said, well, what it is that these people are considering metal? Because when you talk about heavy metal to me, the first picture that comes to my mind is the most metal of the metal bands out there, the super awesome Judas Priest. That's what comes to my mind, right? It's like screeching guitars, screams, and songs about monsters, super cool, etc. That's the most metal among the metal bands, right? But what I have seen in many magazines, Rolling Stone and things like that, is that sometimes people call other kinds of bands also heavy metal. And I tend not to call those things heavy metal. That is not really metal. It's something else, I don't know what, but it is not metal. Nothing against Bon Jovi, I like Bon Jovi, but it's not metal, all right? So that's the skeptical thing, right? We need to ask ourselves, is the data set measuring what it's supposed to measure? That's the first thing that we need to consider, The second one is actually a principle, the first principle of visualization. When exploring your data, and you have heard a lot about these during the day, probably today, when you are going to analyze your data, always visualize your data, right? This is a principle that was taught by the founding fathers of the field of data visualization, people like, for example, the statistician John Tukey, who wrote a wonderful book back in the 70s called Exploratory Data Analysis, EDA, which is a book that we can still read today. It's a wonderful reading. So what Tukey said in that book is always visualize your data. Why? Why should you visualize your data? Because if you don't visualize your data, if you only rely on summary statistics like the mean, the median, the mode, the standard deviation, the variance, etc., there may be features in the data that may go unnoticed. Statisticians sometimes use devices like this one to illustrate that point. This is called the Anscombe's quartet. You can find it online. There's plenty of examples of it and plenty of articles that discuss it. So the Anscombe quartet is basically a series of 4 data sets with 2 variables each, x and y, but that share exactly the same summary statistics. All the variables in those data sets have the same mean, the same variance. The data set have exactly the same correlation coefficient. So if you don't visualize, but then when you visualize them, when you show them, when you create a scatter plot to visualize the distribution and the relationship between the 2 variables of each data set, you will notice that they look very different. Because in some cases, you certainly have a linear relationship, like on the one on the upper left corner, but then on the others, you have outliers that skew the data. Those kinds of things may go unnoticed if you don't visualize your data, if you don't get a sense, almost a physical sense of the shape of your data. That's one of the purposes of visualization. Get a sense of how the data looks like. That's the reason why we need to visualize it. So always visualize your data. Second principle is also extremely important, right? If you want to create effective data visualizations, you need to represent your data proportionally. This sounds like a no-brainer, but we have plenty of examples out there that basically break this principle. Let me show you an example. This is a graphic that was shown by Venezolana de Televisión a few years ago. There was a presidential election in Venezuela, where you had Nicolas Maduro, the current president of Venezuela, on one hand, and Enrique Capriles, the opposition party leader, on the other hand. And the bar graph that you have in there shows the results of the presidential election. If you take a quick look at the graphic, which is what happens when you see a graphic on TV, you don't read the numbers, you just take a look at the shapes, you may notice that Maduro probably had around 10 times the number of votes of Enrique Capriles, right? It looks like that. You have a huge red bar, a smaller blue bar, but when you actually read the numbers, you will notice that perhaps there is something wrong in there, right? There's a very basic rule in data visualization, which is that graphics that use height or length to represent your data, like the bar graph, need to have a 0 baseline. If they don't have a 0 baseline, you're basically distorting the data. That rule, by the way, doesn't apply to all graphs, okay? Only to bar graphs and the variance of the bar graph. A line chart, a scatter plot, they have a different baseline depending on what you want to show. But a bar graph, there's no exceptions to the rules. It does need to have a 0 baseline because otherwise you will not be telling the truth. Third principle, a visualization, this is a very important one. A visualization only shows what it shows and nothing else. Don't try to see more in the visualization than what the visualization is showing. This sounds a little bit obscure, so I'm going to illustrate it with a fun example. A few years ago, I was browsing the internet, and I stumbled upon a series of stories that said that there is a connection between chocolate consumption and the number of Nobel Prizes. So I said, I saw a story that said, for example, I'm going to read some of these titles, chocolate and Nobel Prizes linked in a study, correlation between countries' chocolate consumption and Nobel Prize winner, surprisingly powerful. Eat chocolate, win the Nobel Prize, I wish. Eating chocolate may help you win the Nobel Prize. That's surprising. Study links a country's chocolate intake to how many Nobel Prize winners it spawns. Now, where all these crappy stories came from? And how many times have we seen stories like this in the media, right? Drink more green tea, become as strong as the Hulk in the Avengers movie or something like that, right? So how many times have we seen stories like this? Well, it all comes from an article, not even a study, an opinion article published in the New England Journal of Medicine that includes a scatter plot that very clearly shows that there is a very strong correlation, very strong indeed, between chocolate consumption per capita, kilograms per year and per capita per person on the x-axis, and then on the y-axis you have Nobel Prize winners per 10 million people, and the correlation is extremely strong. R is almost 0.8, which is a very, very strong correlation. So the more chocolate consumption, the more more Nobel Prizes, right? We all have heard that old saying, correlation doesn't equal causation. But we jump to that conclusion automatically and unconsciously all the time. That is the source of the stories that were published in the media. Even in the New England Journal of Medicine article, sort of described that there may be some sort of connection between chocolate consumption and cognitive performance. That was the article. The article was explaining that consuming chocolate makes you more intelligent in the short term. So it makes you more aware and faster. But there is a long, like a huge leap between making you more intelligent in like half an hour and making you win the Nobel Prize, right? So that's a huge leap of faith, right? So, and not only that, I mean, if you jump to the conclusion that chocolate consumption explains Nobel Prizes, that is not what the chart is showing. The chart just shows that there's a correlation between those two variables. I could perfectly argue that the fact that Nobel Prizes and chocolate consumption are correlated is because when a country wins the Nobel Prize, the population tends to consume more chocolate just to celebrate. How do you prove me wrong? You cannot prove me wrong, right? Well, I don't really know why we journalists tend to take these kind of stories seriously, but it happens all the time. And not only journalists, by the way, this is just an aside, very serious journals like the Journal of Nutrition published they tried to debunk the original story. This is an actual paper that was published in the Journal of Nutrition saying, how dangerous it is to overinterpret correlational analysis and infer some sort of causation. And basically, obviously, these people pointed out the obvious thing, that there is a lurking variable in there, which is wealth. Wealth is correlated to Nobel Prizes. Wealth is correlated to chocolate consumption. Wealth is correlated to all these things. So that may be the underlying variable that explains everything. So these people sort of made some fun of the original article saying, well, you could correlate Nobel Prizes with anything you want. I can correlate it with wealth, and they did that. We can correlate number of Nobel Prizes with wine consumption. So the drunker you get, the smarter you get. And my favorite one is number of IKEA stores. The more IKEA stores a country has, the higher the number of Nobel Prizes. And if you take a look at the correlation coefficient, it's actually higher. It's actually higher. So I developed my own theory, which is it's not wine, it's not chocolate, it's IKEA's meatballs that make you smarter. So don't see more, that's the IKEA thing, I love it. So don't see more than what the graphic shows. A graphic only shows what it shows and nothing else, Principle number 4, very important too, and we are getting to the end, so we have plenty of time at the end. So a visualization must always include the right amount of data. What is the right amount of data, and why I highlight this principle? I come from a world, the world of journalism and graphic design, in which people are obsessed with simplifying information, showing the minimal amount of information. I have heard the word or the verb to simplify or simplification all the time in newsrooms. Let's simplify, because people don't read anymore, people don't want to see tons of numbers. Let's simplify this data set, and let's make it clear to people. Well, there is a difference between simplicity and clarity, or between, simplification and clarification, which is the term that I prefer. Visualizations don't simplify. Visualizations clarify. And in order to clarify, sometimes you need to reduce the amount of data that you show, that's for sure. But sometimes you need to increase the amount of information that you show in order to put the data in context. If you don't show the extra data, you're going to miss very important context. So never think about simplification. Always think in terms of clarification. So let me show you an example. A while ago, I learned that the people who work at the White House decided to print out that map, frame it, and put it on the walls of the White House. So I would like to argue that that's a very bad idea, because that's a very bad map. It's a very, very bad map. Why is it a bad map? Well, basically it's showing the results, by the way, of the most recent presidential elections, who won on each one of the counties. That's the map. So red is for the Republican candidate, and blue is for the Democratic candidate. That's a very bad map on its own. It's perfectly fine. It's not a bad map on its the design is not bad, but when you present it on its own, isolated, it may make people jump to the wrong conclusions. Why? Because it looks like a sea of red with a few spots of blue here and there, right? It misleads you somehow when you show it on its own. It doesn't take population into account. The fact that these states or the counties in which the Republican candidate won are more sparsely populated than the counties where the Democratic candidate won, right? So perhaps we could come up with alternative solutions to that map, or at least complementary maps that we could put side by side. When you put those maps side by side, you get a better understanding of the picture. You still see geographically who won on each county, which is perfectly fine, but then you take population into account, so it doesn't look like a 80 versus 20% election. It's more like a 50-50% election, which is what actually happened. And then the map down there is called a cartogram. The one on the upper right corner is called a proportional symbol map, which uses bubbles to represent population in this case, and the color is the method of encoding for the winner on each one of the counties. This one down here is called a cartogram, which is a wonderful representation of data. In that case, each one of the states is proportionally sized according to the number of electoral votes, which is a very important metric if you want to understand what truly happened in the past election. So if if the White House consulted with me, I would actually recommend not to use that map. I actually offer myself on social media to give the White House staff a free lecture, a free workshop on better visualization practices. They didn't take me seriously, nobody replied, but the offer still stands, okay? Okay, principle number five. Whenever it is possible, when you're going to present data to other people, try to build narratives with your data. But a little bit of a warning before I proceed and show you an example. It's not always possible to create a narrative with your data, all right? Sometimes it is not possible, and you just need to present your data to your customers or to your readers and let them explore the data on their own. But whenever it is possible to build a narrative on top of the data, if you can do that, that's one of the most effective ways of representing data. So let me show you a project of mine that I designed in 2010. It's a big visualization poster that I designed for a Brazilian publication. I am originally from Spain, but I worked in Brazil for 2 or 3 years for an organization called Globo. So back in 2010, the Brazilian Census Bureau released their most recent data, right? The census survey was released in 2010. So the results of the census survey show that Brazil's population increased from like 170 million people up to 190 million, almost 200 million people. And then we represented the variation of the population on the first half of the graphic. The variation of the population, we showed it at the national level, at the state level, which is the second graph that you have in there, and then at the local level. That is what the map is showing. This project, I'm going to show it again just so complete, because this is only the first half. As you can see, it's a print project, but it could be, the structure of it could be the same if we did this project in online media, like to display on a mobile screen or something like that, or on a computer screen. And it's not interactive, obviously. Anyway, so the first portion of the graphic tells you, yes, Brazil's population grew between 2000 and 2010, right? And we could have stopped in there and not tell people anything else. But when I was taking a look at the data provided by the Census Bureau, I discovered something else, all right? Not that I'm particularly smart, obviously, because it was there for anybody to see. I discovered that there was something interesting about the fertility rate, right, of Brazil. Now, the fertility rate is the average number of children per woman in a country, right? So if you go, for example, to Europe, to countries like Spain, fertility rates are really low. The current fertility rate in Spain is like 1.2. That doesn't mean that women tend to have 1 child and then have a children. It just means that that's the average, right? It's 1.2 children per woman. That's the number in Spain. If you go to Germany, I believe that is 1.7 or 2, something like that. If you go to the United States, I believe that is something like 2 point something. If you go to developing nations, to poorer nations, for example, if you go to Afghanistan, I think that in Afghanistan, the current fertility rate is something like 6 point something, so 6 children per woman. So very poor nations tend to have, higher fertility rates. Now, I'm going to ask you another question, and you are 3,000, so I'm not going to ask you to reply to me. That would be fun, but I'm not going to ask you to do that. Just picture the answer in your brains. Now that I have told you that developed nations, rich nations, tend to have low fertility rates, and developing nations tend to have higher fertility rates, what is the fertility rate of Brazil? And I bet that the number that came to your mind is something close to 3.0. That's the number that comes to the mind even to Brazilians. If you do these tests to Brazilians, most of them will tell you a number between 2.6, 2.8, 3.5, even 5 in some cases. Why? Because when we think about Brazil, we think about samba, and we think about fiesta, and we think about, carnival, and the northeast of the country, which is sun and beaches, etc. But Brazil is a nation that has evolved a lot in terms of economic development. If you go to the south part of Brazil, for example, the state of Santa Catarina or the city of Porto Alegre, it's like walking in Europe. It is cold, and it rains, and people go to the beaches, but only during the summer. And moreover, women are accessing the workforce in increasing numbers, and that delays the time when they're having children. So, just to spoil you, the current fertility rate of Brazil is 1.8. which is incredibly low, and that is what the second part of the graphic shows. The fertility rate of Brazil, which is the green line on that line chart over there, has experienced one of the largest drops in the past 50 years. It came down from 6 point something back in the 50s down to 1.8 in the present time, or at least in 2010. This is the time when the graphic was published. It is so low, actually, that it has come below the replacement rate. The replacement rate is the minimum number of children per woman. Right? That's a number that demographers calculate. The minimum number of children per woman that a country needs to have in order to keep the population stable. That number currently is 2.1. If your fertility rate goes down 2.1, your population will start growing, will keep growing in the near future, but at some point it will become stagnant and it will start dropping. Okay, that's what's predicted. That is going to happen to Brazil. It's a line chart that you have on the upper right corner. It is predicted that Brazil's population will grow up to 230 million people, and then it will start dropping right after that in the future, around 2020. That's a prediction that demographers are making. And another consequence of having a very low fertility rate is that your population pyramid will change a lot. The current population pyramid in Brazil looks like an actual pyramid, okay? Tons of young people down here and much fewer older people over here. But the population pyramid of Brazil, predicted for 2050, looks like a square. There is going to be still quite a lot of young people down here, but tons of elderly people over here. That is going to pose a huge challenge to a country like Brazil, because Brazil has public health care, public retirement, public services available to everyone. So that is going to put a lot of pressure in those services. So how can Brazil prepare itself for that situation? Now, if you notice, I have just told you a story. This follows the structure of a traditional narrative story, right? You take a look at this is the whole poster. And actually, if you only read the titles of the graphic, the titles tell you the entire story. And then the graphics provide the evidence for what the titles are saying. Because the titles are saying, title number one, Brazil's population grew, but fertility rate is way below expected. The first consequence is that population will become stagnant and will start shrinking in the near future. The second consequence is going to be that our population is going to become older. How can we prepare for this situation? So traditional narrative structure, opening, conflict, consequences of the conflict, resolution of the conflict. That's the traditional narrative circle that theorists of a narrative talk about all the time. So whenever it is possible to shape a story like this or a presentation like this, try to do it. Now, I didn't learn to structure stories like this on my own. I copy people all the time. That doesn't mean that I plagiarize people, that I copy from the best, all right? I borrowed this idea, this way of structuring stories, from friends of mine who work in places like National Geographic Magazine or Vox.com. The head of infographics at Vox.com, his name is Javier Serracina. He's also from Spain, by the way. And the head of National Geographic is from Spain as well. There's something going on with Spaniards and infographics in the United States. Well, that's an aside. Anyway, so Javier once explained to me the way he creates data stories. And it's absolutely wonderful. He doesn't begin with the visuals, and I don't begin with the visuals because I copy from the best. I begin with the text. Whenever I'm going to shape a story in visual form, I begin, copying Javier, by writing a very long sentence. And the long sentence, I have just told you, I'm going to repeat it, is Brazil's population grew bigger between 2000 and 2010, but fertility rate is below expected. This will have these consequences, will have another consequence. How can we face the situation? That's the long sentence. Then you try to find the natural breaks of that sentence. You cut that sentence up into those pieces. You transform those pieces into the titles of each one of the portions of the graphic or each one of the slides of your PowerPoint presentation, and then you illustrate each one of those titles using the visuals. That's one of the most successful strategies for data stories that I have ever thought about. Well, I didn't think about it. I stole it from Javier, obviously. And then the final principle, which is a very important one. I have been pointing out basic principles of visualization, basic principles of data representation, etc. I would like to go back to the original theme I began with. A visualization is a tool. A visualization is an instrument. A visualization is something that we use to expand our cognition and our perception. We need to educate ourselves in principles of visualization. We need to expand our knowledge about principles of visualization. The tools are only the beginning. When I say tools, I mean the software tools are only the beginning. The principles are much more important. So just to make an analogy, going back to the analogy that I made at the very beginning, for me a visualization is not that different than a hammer. A hammer, as I said before, has a particular shape because it has a particular purpose. But it could have more than one purpose, right? A hammer can be used to build, right? We can build houses for the poor, help people have better lives. It can be used to build, but it can also be used to destroy. And that's the problem that we're facing nowadays with the challenge of bad data, bad visualizations, alternative facts, and all the problems that we are facing. So we need to make a choice. Visualization is not just a matter of creating graphics that are efficient at representing the information. That is only the beginning. We also need to think about ethics. We need to think about representing our information ethically, creating visualizations that don't just push agendas or sell ideas or products, but graphics that help people understand the world that they live in, graphics that enlighten them, graphics that help them learn something useful about the world that surrounds them. And with that, I would like to close the presentation today. Thanks so much for coming.